Good morning, children. Today I'll be teaching the new lesson. Lesson name is sound. It is one of the interesting chapter. It's a part of physics. So what is meant by sound? Sound is a form of energy produced by vibrations. So it is a form of energy. Sound, one of the light is energy. Sound is also a form of energy. It is produced by vibrations. Sound plays an important part in our daily lives. It helps us to communicate with each other. We hear a wide variety of sounds in our surroundings. Sound is produced by a vibrating body. So how sound can produce? It is produced by a vibrating body. Vibration is, what is meant by this vibration? Vibration is the to and fro or back and forth motion of an object. That is called vibration. Vibration is to, front and back, or to and fro or back and forth motion of an object. It is called vibration. Few examples they given. If you strike a school bell, it vibrates and produces a sound. First figure you can see here. Same like in the second case, if you pluck a stretched rubber band, it vibrates and produces sound. Third, if you beat a drum, third one, look at this. If you beat a drum, its stretched membrane vibrates and produces sound. The last one you see, look at this. If you blow a bugle, the air column vibrates and produces sound. So all these are examples for objects which produce sound. Yes, they given some pictures of some musical instruments here: tabla, veena, guitar, like this, violin, all this. The next one is production of sound musical instruments. Production of sound musical instruments depends on the type of instrument. There are four types: woodwind, string, percussion, brass. So which are the four types? Woodwind, string, percussion, and brass. Let us see one by one. First one, it is woodwinds. Woodwind instruments. Woodwinds instrument make music by blowing on the top or on a reed of the instrument. Flute, oboe, clarinet, piccolo, bassoon, all these are examples for this woodwinds instrument. The next one is string instruments. String instruments make music by plucking or strumming the strings. Okay, you can look at this violin. How they will make sound? They make music by plucking or strumming the strings. Violin, cello, guitar, electric guitar, harp. All these are examples for these string instruments. Then third one is percussion instruments. Percussion instruments make music by striking, shaking, or scraping them. Drum, tambourine, piano, cymbals, xylophone, maracas. All these are the examples for percussion instruments. The next group, it is bass instruments. Brass instruments make music by buzzing lips while blowing. French horn, trumpet, trombone, tuba, etc. All these are examples for brass instruments. Then, yes, again, you can see here some pictures of the musical instruments. Musical instruments and their vibrating parts. So in the left side, they given the name of the musical instruments. The right side, vibrating part producing which part of that instrument, how they produce sound. Okay, first one is veena, stretch string, sitar, stretch string, violin, stretch string, guitar, stretch string, tabla, stretch membrane, mridangam, stretch membrane, drum, stretch membrane, Chennai, air column, flute, air column, mouth organ, air column. All these are the different musical instruments. Then these are the vibrating part which produce sound. Then musical instruments. Some musical instruments produce sound when they are beaten or struck. Examples they given: bell, ghatam, manchira, jaltarang, etc. So these are the pictures. First one is bell. So how they produce sound? Some musical instruments produce sound when they are beaten or struck. Okay, first one is bell, second ghatam, third manchira, fourth one is jaltarang, etc. These are the examples. Then sound produced by humans. How we will produce sound? From which part of our human body we can produce sound? In human, sound is produced by the voice box or larynx. What it is called? It is called voice box, or it is also known as larynx. It is the upper part of the windpipe. You know, we have foot pipe and windpipe. This upper part of the windpipe, that is voice, that is known as voice box or larynx. Two vocal cords are stretched across the voice box, leaving a narrow slit. You can see here, this is one, this is another one. Two vocal cords, in between there is space or slit, you can see. Clear. Two vocal cords are stretched across the voice box, leaving a narrow slit. When the lungs force air through the slit, it vibrates and produce sound. So look at this. You can see here Adam's apple, okay, that you studied in the last session. What is Adam's apple? This voice box for boys. The voice box, it will enlarge and it will protrude out. That is called Adam's apple. Here, this is the area above vocal cords. This one. This is area above, sorry, area beneath vocal cords, then area containing vocal cords. So this is a part, area containing vocal cords. Clear? So same like this part is glottis, then cricoid cartilage. This cartilage is known as cricoid cartilage, thyroid cartilage. Here only this next to that only thyroid gland will come. So this is thyroid cartilage, then vocal ligament, then arytenoid cartilage, then cariculate cartilage, then cricoid cartilage. These are the different parts of the vocal cord. So there is a one pair of two vocal cords are stretched across voice box, leaving a narrow slit. So through this narrow slit, through the narrow space, when the air is passing through this, it will vibrate. These two vocal cords, it will vibrate and it will produce sound. Then sound produced by animal. Animals like dogs, cats, horses, lion, cows also produce sound by their vocal cords like human beings. But there are some other animals or other organisms, they produce in different way. Birds produce sound with ring of cartilage called syrinx in their windpipe. So how they make sound? With a ring of cartilage called syrinx in their windpipe. Insects like mosquitoes and bees, etc., produce sound by vibrating their wings rapidly. How they produce sound? They produce sound by vibrating their wings rapidly. Insects like mosquitoes, bees, etc. The next one is frogs produce sound by puffing their vocal sacs up their throat like balloon while croaking. The next one is propagation of sound. Sound requires a medium to propagate. Okay, from one place to, if I am talking, you people can hear. Okay, how is it possible? Because they need some medium to propagate. Sound travels through solids, liquids, and gases. Sound does not travel in vacuum. So that is the reason if you are going to the space, if you are going to the moon, you can see that if two people are standing and talking each other, they can't hear each other because there is no air. So they need any one medium to travel. Sound does not travel in vacuum. Example, sound travels through the solid thread of a can telephone. Children usually they will play. They will make by using matchbox. They will make phone. Inside they will be tying a thread in both the sides. They will be playing like telephone. So sound travels through the solid thread of a can telephone. A whale listens to the reflected sound echo in water to locate its prey. Say, whale listen to the reflected sound. The sound will go and it will reflect back, reflected sound. It's called echo in water to locate its prey. Then we are able to listen to sounds because sound travels in air. Air means mixture of gases, that is called air. So we can hear because the sound travels through the air. Then speed of a sound. Speed of a sound depends on few things. First one is elasticity. What is meant by elasticity? The ability of an object or material to resume its normal shape after being stretched or compressed. It is called elasticity. Okay, you can take any elastic rubber band or elastic band. You just pull it, it will expand. We will tell it will expand, and just leave it, it will contract and come back to the same place. Okay, so that is called elasticity. Okay, rubber band is also best example. Elasticity, the ability of an object or material to resume its normal shape after being stretched or compressed, that is called elasticity. Second point, the speed of a sound depends on the density of the medium. The medium may be solid, liquid, or gas, any medium, the thickness, the density of the medium through which it propagates. The, Based on that, the speed will change. Speed of a sound will change. So mainly, the speed of a sound depends upon, first one is elasticity of the material, second, the density of the medium. In case of air, it also depends upon the temperature of air. So suppose in the case of air, we are talking each other. I told the air is passing through the uh, what is sorry, sound is passing through the air. It also depends upon the temperature of air. The speed of sound through air is about 330 meter per second. The speed of sound through air. What it is speed of sound in air? 330 meter per second. The speed of sound through water is about 1500 meter per second. So the speed of sound in which if you are taking three medium, solid, liquid and gas, in solid it is greatest. The solid is greater than liquid, liquid is greater than gases. The speed of sound is in gas is least. Okay, so least in gas and more speed in solid, then lesser in liquid, then least in gases. The relationship between speed, frequency, and wavelength. We are going to learn the next topic. What is the relationship between speed, represented by V, velocity, frequency, okay, frequency, actually it will tell gamma, and wavelength, lambda. Speed is equal to wavelength into frequency. What is the formula? Speed is equal to wavelength into frequency. Clear? So speed, velocity V, wavelength, it's a lambda, then frequency is called gamma or nu. In Greek letter nu it is. So speed is equal to wavelength into frequency. V is equal to lambda into gamma. The next is speed of sound in different media at 25 degree Celsius. So here they given one constant temperature 25 degrees Celsius. So what is the speed in different medium? Solid, liquid and gas. In solid, they have taken aluminium, steel, iron, brass, glass. You can see the speed is different. Here 6420 meter per second for aluminium, then steel 5960 meter per second, iron 5950 meter per second, brass 4700 meter per second, glass 3980 meter per second. Same like if you are taking the liquid at constant temperature 25 degrees Celsius, you can see you have to take different liquids like water. This is seawater, distilled water, ethanol, methanol, like this. The speed it differs. It is different. You can see different speed. For water, seawater 1531 meter per second, distilled water 1498 meter per second, ethanol 1207 meter per second, then methanol 1103 meter per second. If you're taking the gas, you can take hydrogen, helium, air, oxygen, sulfur dioxide. Here also the speed is different for a different type of gases. Excuse me. Hydrogen it is 1284 meter per second. Helium 965 meter per second. Air 346 meter per second. Oxygen 316 meter per second. Sulfur dioxide 213 meter per second. So here speed it differs. It's different. Yes, if you're taking speed of light versus sound, you can see the light also travels, it also travel in high speed. Even sound also can travel very speed. Will let us see which will uh, move very fast. Okay, the speed of sound in air is 330 meter per second. The speed of light in air is about 3 into 10 raised to 8 meter per second. So what is the speed of sound in air? 330 meter per second. The speed of light in air, it is 3 into 10 raised to 8 meter per second. Speed of light is faster than speed of sound. So which is more faster? Light. Okay, speed of light is faster than speed of sound. That's why the thundering sounds are always heard a little after seeing the flash of lightning. So during rainy season or rainy time, always you can see this lightning and thunder. Which you will see first? You will see first lightning, then thunder. You will hear thunder sound. The reason is light is faster than sound. Understood? The speed of light is faster than speed of sound. That is why the thundering sounds are always heard a little after seeing the flash of lightning. Both the lightning and thundering occur together. Delay in hearing is due to the difference in the speeds of sound and light. Okay, that is the reason we can see the seconds delay. First lightning we will see, maybe after 2-3 seconds only we will hear the sound of thunder, because which has more speed than light. Light has more speed than sound. Yes, vibration and oscillation. Vibration is the to and fro or back and forth motion of an object. Vibration is also called oscillatory motion. What is another name for vibration? Oscillatory motion. What is meant by oscillation? The motion of the pendulum from one extreme position to the other extreme position and back is called an oscillation. A to B and back to A. Okay, always you can see for the pendulum of the clock, it will move from one point to other, again it will come back to the same position. Okay, that is called oscillation. The motion of the pendulum from one extreme position to the other extreme position and back is called an oscillation. The same like A to B and back to A. So that is one oscillation. Then what is meant by frequency? Frequency of sound wave. The number of oscillations per second is called frequency. So what is frequency? How many times it will oscillate in 1 second, per second, in 1 second. The number of oscillations per second is called frequency. So what is meant by frequency? Number of oscillations per second is called frequency. It is represented by a symbol, Greek letter nu. The unit of frequency is hertz. HZ, that is a short form. So which is the unit of frequency? The symbol is different, unit is different. The symbol I told it is represented by like this, almost like V. It's a Greek letter nu. The unit of frequency, it is hertz, HZ. Then time period of sound wave. What is meant by time period? The time taken for one oscillation is called time period. So what is meant by one oscillation? From the point A, it will come to B. Again from B, it will come back to A. So that is one oscillation. Okay. So the time, how long time it will take, that is called time period. The time taken for one oscillation is called time period. It is represented by the letter T. Time period represented by the letter T. The SI unit is seconds. What is the SI unit? SI unit is second. Frequency and time are represented as follows. T is equal to 1 by frequency. Time period means time taken for one oscillation is time period. So time period T is equal to 1 by frequency. So frequency or nu, it is called nu for one oscillation. Frequency for one oscillation equal to, this is a frequency, equals 1 by T. Clear? Frequency is equal to frequency. This will be coming to the side. So T, it will come to opposite side. So 1 by down. So here 1 by T. Frequency is equal to 1 by T, 1 by time period. So that is a formula for frequency. Frequency is equal to 1 by time period. Thank you, students.